So sadly, I've lost some of the video of some of the wiring I did here, but I'm back today to kind of try to finish this up. So I'm going to do a couple of things here. In the assembly manual, one of the things he had you do was kind of bend the pins here on the RS-232 module down to get clearance under the PCB, and I didn't have a lot of luck with that. I put the little connectors on and I bent it down, and then the connectors became so loose they fell off. I've kind of played in here trying to decide how I actually want to put this together, because I'd still like the RS-232 adapter to be able to be moved around to different UARTs potentially if I want to. So I think the decision I'm come to is I'm going to remove the RS-232 board, and I'm going to hardwire these 4 wires directly into it. And then I think I'm going to go ahead and mount the pin headers here on the back of the PCB. And I'll bring the wires underneath and jack on, and I think that should give me plenty of length. You know it really well between the back of the case. For these to be connected on the back, they'll be hard soldered onto this board here, which I think will make things work a little bit better. So again, this is just kind of my preference. So I didn't have a whole lot of luck just getting everything lined up with the pin headers to really connect in a way I was comfortable with. So we'll go ahead and move the little board here, and I'm going to hopefully be able to unsolder that pin header. Looking at the color of the solder that's there, it was done with lead free. I'm going to add a little bit of regular leaded solder just because it'll make it easier potentially to unsolder. So we'll do that now. Yeah, these really don't want to flow well. Not a big fan of lead free solder. Just doesn't work as well. I've got the desoldering tool heated up here. And we'll see if I can get these to unsolder and remove. See if that actually released, and it feels like it did. I can see the pins wiggling. Nice, so that just walked out of there cleanly. This is the one where multiple insertions and torque and stuff through. It's loosened these ends up over here enough that I'm really not happy mechanically with the connection, so they result in. So I'm going to go ahead and just clip those off. Strip a bit of lead back on these. Oh shoot. Oh shoot, what the heck? Huh. That was really soft. And because the lead that comes over to pick up the 3.3 volts is shorter, I'm going to be able to use this slightly shorter red lead to reach, and I think the longer leads will reach over to the connector over here just fine. So let's tin these up a bit and see what we get. Actually, I'm going to start with just one. I'm afraid with them tinned, they'll be too large a diameter to get through the holes on the PCB, but I'd still like them tinned up. So we'll kind of see how this goes. The lab has become, or the bench here has become an absolute mess. It would probably be wiser to clean it up to continue the assembly, but I say that doesn't mean I'm going to do that. Let's see if I can have any luck tinning one of these up. I'm going to use red, of course, for the VCC. through just fine. So let me tin the other 3 up. You know, the one ended up a little bit shorter than the other 2. Not that that's really going to matter. A little bit of difference in length. Now these are just bare copper, whereas that red lead I used was actually tinned copper. These might be a little more difficult to get to take solder. We'll find out. Well, that took solder nice and readily. Mechanically, these aren't going to be the best connection. I'll probably come back with some hot glue just to reinforce these. Figure out a way to position this board. That worked really well, obviously. Hopefully this is somewhat on camera. Take the red lead, feed it on through. Try to get it poking through the board nice and straight. We'll see if we can get that to solder up sufficiently that I'm happy with it. And I'm okay with that. We'll use one of the white or gray for data. The gray one here again for data. In this case, this one's just going in to receive. It's got a little bit of a solder ball on the end, keeping it from wanting to go through the hole on the PCB. But that got it so it went through. Of course, it came loose. Man, I really can't keep it under tension. There we go. You know, this isn't going to be in a high vibration environment or anything like that, so not too worried about these mechanically. And of course, I'm going to use the black for the ground connection. So there is a bit of color coding here. And I think I like that a little bit better. That way the pins don't have to be bent, sloping down on this like it showed the instructions to clear the edge of the PCB here. Should be able to put that back in the case now. So I'm just going to make a note here. I've already got one here. So VCC is of course red. VSS is black. And for transmits data, I used white. And that means for receive data, I used the gray. So, sorry, I'm sitting here as I always am, swapping glasses. See if we can get this back in without doing too much damage to everything here. And get you to go through and not drop off the little metal case. Start that one. That's not too bad. I'm going to install pin headers on the back of the PCB. So I need 4 pins for there, and I need 1, 2, 3, 4, 5, 6 times 2. Now I have soldered in pin headers a couple of times into this and removed them. Looks like that's going to hang there okay. Get a bit of solder to tack it in place. Hopefully. It's tacked in and it's flush so we can solder it. And I think there'll be plenty of room underneath for those. Wow, the bench has really become a disaster. For the leads to be able to slide onto these. I thought about doing this on the top of the board with the pin headers on top, but the height of the little connector over the pin was just at the limit of what I think would work. And I didn't want them actually touching the front panel and bowing it out slightly. So this is why I've elected to do this on the back of the PCB. Good enough. Let's go ahead and fit you up through and just temporarily hold you in with a little bit of tape. It looks relatively square. Not quite square, so I'll manipulate it a bit. Still overall impressed with the quality of the kit. Mechanical layout, etc. So now remember that the RS-232 module here requires 3.3 volts. I think he talks about that in the manual here someplace when he actually has you do the wiring. Oh, you know what? Yeah. I just misinterpreted the manual the first time I did this. He actually is working on the back of the PCB, just like I just did. So the first time I mounted these on the front of the PCB, I did it incorrectly. Just, again, not paying enough attention to the manual. So I've just done exactly what he told you to do in the manual. So stupid me. 3.3 volt is the second one down over here. Ground is the second pin in here. We said white was transmit from the board, this board down here, so it'll go to receive. I've got ground on the wrong pin. Second pin down, so white will go to that third pin, if I can get it on there. And we said gray was receive on the RS-230 board, so it'll go to transmit over here, which is the pin down here on the bottom. Okay, that's much better. So really the only thing I did different from the manual was just solder those leads directly onto the RS-232 driver board. So I think we're good there. Now it's kind of dealing with cabling. The USB lead goes into here for the picture. And plugged it in here on the programming jack, the jack they're labeled programming. This is going to sit down in here. We've got to manipulate the cable here a bit for the USB to get things to sit in flush. Is that? I see. I've got the cable. How am I going to route that? I think that's about it. I believe these little plastic nuts go on the that's a little tricky to do. On the threaded standoffs, so I just want to get those started to just kind of hold the board in place on that end. I'm not going to really tighten them up. There should be 2 screws, which are here, which are what come through on this side. I can see the standoff's in pretty good alignment down there, so we can drive him in, assuming I can find a screwdriver here in the mess. See if the little CF card lines up. And it does. These are turning into nylon spacers, so I don't want to make them super tight. That's not bad. I'm going to tighten the little nylon nuts over here up just a bit. Shouldn't need to be super tight. mechanically that's got it. Always swapping between glasses. Where did I put them? So we've got the external DC 9-volt adapter here. And the power switch on the front works with that adapter, which is nice. If I remember right, we set switch 1 up and we go. Nope. Don't remember again how to get it into that kind of little looking test mode. There it is. So we can see it running kind of the, I guess, that little Pong kind of game thing on the LEDs, but there it is. It powers up that far and runs. I can certainly see I've bent some of these LEDs around in handling. Not too bad, but that's okay. So that's a nice sign. I'm going to disconnect that power. I'm going to go straight to USB power. And I don't honestly know if it'll power off this USB port or not. I guess we'll find out. Yep, it powers off that USB port. We can run that same program again. So we got multiple power options. I'm assuming this USB port could be connected back to a serial terminal on a PC. We'll find out as we move forward. Happy with that. Now, compared to the absolute frustration I had last weekend, this has come together pretty simply, and that was due to basically needing to bend those pins down and just having no luck with that process. You know, you may have much better luck with it than I did. But at least mechanically that's all together. The SD card fits in its slot. It wants us to take the adhesive sticker and apply to the front panel. For this, I'm going to move the unit out of the way. Not sure what that's going to do to the white balance, but I'm just going to get something to work on here. That's a little bit longer than the case, which is fine. It mounts something like that. Apply the sticker to the front panel. Adhesive's forgiving. If you place it wrong, you can pull it up and put it back again. So really want that to be as dust-free as possible, so there's not little holes below it. And this should be kind of interesting to get on here square. Peel the paper back, backing paper back some. I have it. Nope. Needed to be a little bit further off the edge. Oh, come on, let's peel this back a bit further. He's correct, that adhesive was forgiving. I want to kind of try to start with it square. And we'll find out how lucky I am or I'm not here. You can tell I need the other glasses. See, has to go a piece of dust under there. Oh well, it is what it is. Still doesn't look bad. I'm going to assume I can use the X-Acto to kind of trim off this extra length. Wow, it would really help here if I cleaned the bench. It just really would, but see if I can cut that, trim it off. Without scoring it or wrinkling it. It's nice and square to the edge. It's not bad. Doesn't look too bad. Got something stiff enough to poke a hole through there so I can see where the screw holes are. And then he basically said use a small, say, Phillips screwdriver to open those holes up so we can get the little bolts through. That is a departure from the original front panel, but it'll be fine. This isn't meant to be a exact picture perfect clone. That's going to be too big. Kind of used to kind of poke through there now that I have pilot holes. Really, I think the next step here is bringing it back. All of those switches down. That kind of makes it easiest to drop the front panel down on. I'm having a little bit of an alignment issue here. I think I'm going to have to loosen up the screws here. Get a little bit of slack for things to kind of shuffle around. What are you hitting on? I'll loosen up these two little nuts here as well, just so that the board can slide around a bit. And maybe that'll give me enough kind of slop. There we go. That just took a little bit of a coaxing, these are actually going to line up into the internal standoffs. How far off is that? It's not too far off. That one started. So really this is the one that's being stubborn. There, it caught. Like I said, these don't need to be super tight, just snug. Nothing here needs to be super tight. You are working with nylon spacers and nuts, etc. here for the majority of this, so trying to go too tight will just simply yeah, I didn't think that was the right size. We'll just simply strip the nylon. This doesn't need to be astronomically tight. So power is off. We'll bring in the DC 9 volts. We'll power up. It's awake. Very nice. Good looking little kit overall. You know, for what it is, I think it plays homage well to the original machine. I'll have to compare it to my I've got a replica downstairs that's much more accurate. Well, I shouldn't say much more, that is more accurate mechanically. It's got the blue case, the whole 9 yards. It was very expensive. This is actually a much nicer piece for displaying. This can just sit on a shelf. But that's very cool. I believe the SD card goes in this way. I don't know how to load software from it yet. I did order the preloaded SD card when I ordered the kit. Actually doing something very cool. I should be able to stop it running. Should be able to single step through the program. We saw it light A13. Still runs as expected. So you're seeing here kind of some of the why you have the front panel. I can run the program. I can stop the program. I can single step, which just runs one machine language instruction at a time. Might be in like a timer loop here, looking at the way the LEDs are running. We can set the memory address to 0. Gotta remember how to do this. I want to examine address 0. There's the data at 0. Then I can step up through the addresses and look at the data. So we can see that at address 8, 1248 in decimal, Address 8, we have a 032 in octal. Notice that this is set up in octal. There's a group of 3 bits, 3 bits, 3 bits, 3 bits, 3, 2, and the data is, of course, 3, 3, and 2. So it's an octal machine, not a hex machine. So we can see that at address 10, or 00010, we have a 032. And we can you can see the addresses incrementing here. You can see the data finally changed there at that address. There's address 14, and it's got a 11 in it. And this is kind of the way it was in the early days. You could hand toggle in a program. So we could reset back to address 0. We could toggle in the data we wanted here. We could deposit that data. We put in the next data or instruction we wanted, do a deposit next. Actually, that switch doesn't matter. Deposit next. So in this case, I'm inputting the data that I want on these switches here, which gets written up here, and you can see the address is incrementing. We'll change a couple of bits. Deposit next. You saw the address increment. Deposit next. I can reset addresses back to 0, and now if I do an examine, we'll see the bit pattern I wrote in there. Is that right? Why? Oh, I need to reset the address back to all zeros, and now we see the bit pattern I wrote, and you can see it reading back memory 1 byte at a time, bringing back the bit patterns that I deposited. That should be on camera. So nice little kit. A couple of frustrating things for me. Again, the manual is really nice. I'm going to have to go to his operations page and learn more about how to use it. But that gets the kit together. This is going to display very well. I will be displaying this unit, I think, along with the Kenbeck that we assembled in the previous video. This is full size from the original machine. The Kenbeck here, of course, is like half the size. It's probably 50% the size of the original machine. Of course, the original Altair-8800 was very deep. It was an S100 machine. Took a bunch of cards to do anything. But really, the idea here is the front panel, and just kind of what machines were like in the old days. I was at work yesterday, actually, talking with one of the young guys there. He's really early 30s, and just no experience back in this era of computing. And I talked him through, like on a PDP 1170, toggling in, you know, doing a similar thing here to get the IPL code into memory, actually written into core back when I was in the day. I think it was core, it may have been solid state, I don't remember. Anyhow, getting that IPL code toggled into memory so you could execute it, and that would then go out to a peripheral, like a paper tape reader, and start reading bytes off it into memory. So the IPL would load the bootloader typically, and then you could use the bootloader to boot, you know, an actual OS from something, and kind of talked him through that whole sequence, and he was just kind of like floored that that's how the world used to be. And well, in the early days, that's how the world was. Anyhow, I would think I will wrap this up here. Do a reset. You want to run that program 1 or 2, I guess in this case, just because it does a nice blinky light pattern. And we'll talk soon.